All right, we're on lesson 5.3, fractions with unlike denominators. Unlike yesterday, where you had 1/4 plus 1/4, like denominators, you can add or subtract the way they sit. You just add the numerator, denominator stays the same, and you reduce. That's it. Unlike that, today is fractions with unlike denominators. Can I add these the way they sit right now?
No.
Why not? They have to have the same denominator, right? They have to have a common denominator. They have to have a common denominator. These do not. How do you find a common denominator? Now here's the thing. Let me explain to you. There's two things you can do here. You can either do the hard work up front, or you can do the hard work at the end. Either way, you're going to have to do the work to get a common denominator. The best thing to do is not the best thing. One of the ways to do it is to find the least common multiple of the two denominators. Okay? Sometimes they're real easy like this. The multiples of 2 are 2, 4, 6, 8, right? Multiples of 3 are 3, 6. There they are, right? You agree that 6 is the least common multiple of the two. You have to ask yourself, well, how would I get this 2 to become a 6? What would I do, Joy? Multiply it by 3. Now, here's the deal. This is important. I need to multiply this whole fraction by something that isn't going to change the fraction. You understand what I'm saying? It still needs to equal a half. So I need to multiply that fraction by the number 1 in the form of 3 over 3. Does that make sense? Really, by me multiplying the numerator and the denominator by 3, I'm really only multiplying 1/2 by
0, 1, 3.
Oh my goodness. You guys don't know this?
We know it, we just don't know how to say it.
Right, there we go. You're multiplying this fraction by 1. That's really all you're doing is multiplying it by 1. We're just multiplying it by 1 in the form of whatever is going to make it so that we can add it now, right? We can't add 1/2 and 1/3. They don't have the common denominator. So we have to multiply each of them by something to make it so that I can add them. I'm going to multiply it by 1 in the form of 3 over 3. And then I'm going to multiply this by 1 in the form of 2 over 2. Because by multiplying it by 2 over 2, what is 2 over 2, people? What is that? Oh, what is 3 over 3? Oh, I see. That's all I'm really doing when I multiply this, the top and the bottom, by 3 and multiplying it by 2. I'm multiplying it by 1 in the form of 3 over 3 and by 2 over 2. When I do that, what is 1 times 3? 3. 2 times 3 is 6. Plus 1 times 2 is 2. 3 times 2 is 6. Can I add them now? Yes, because
They have a
common denominator. 3, 6 plus 2, 6 is 5, 6, and we're done.
Yes.
Make sense? We're all with me. That's the easiest possible fraction I can give you that doesn't have a common denominator. Now, what about this? What if I have 7/8, and I'm going to take away 1/12. This is what I mean by you can either do the hard work up front or you can do the hard work at the end. Let me explain. With this, do they have a common denominator? No. They don't. Can I add them the way they are?
No.
No. Because they don't have a common denominator. Agreed? Okay. In order to add or subtract fractions, I have to have a common denominator. I don't. So, this is where there's 2 ways I can do this, Momo. There's 2 ways I can do it. Oh, wait. There's 2 ways I can do it. I can find the least common multiple right now. By me finding the least common multiple right now, I will not have to reduce as much later. Okay? If I take a shortcut here I will have to reduce more likely later. This is what I mean. If I want to, I can multiply this whole fraction by what is, first of all, does it matter what the denominator is as to whether or not I can add or subtract it if they're the same? Does it matter what it is? No. As long as they're the same, I can add or subtract the fractions. Agreed? I could take this whole fraction and multiply it by 1 in the form of that denominator, 12 over 12. And multiply this whole fraction by 1 in the form of 1. In the form of 1 in the form of 8 over 8. You see that this whole fraction is multiplied by 1 in the form of 12 over 12. And this whole fraction is multiplied by 1 in the form of 8 over 8. Here's what I'm saying. When I do this, it gives me 84 over 96 minus 8 over 96. Here's the deal. At this point, can I subtract them?
Yes.
Why can I subtract them? Because they have a common denominator. 8496 minus 896, it ends up being 7696. Am I done? No. Here's the reason why I took the shortcut and just grabbed the denominator here and multiplied it here, and grabbed this denominator and multiplied it by here. You see what I'm talking about? The problem is now I have to reduce this. Do you agree with that? Mm-hmm. Divide it by 2, divide it by 2 is 38 over 48. Am I done? No. 19 over 24. Now I'm done. It took more time at the end for me to find the proper reduction of it, right? The other thing I could have done, let me give it again. It was 7/8 minus 1/12, right? Caleb said, why not? What if I had found the least common multiple at the beginning? That takes some work to find the least common multiple. Don't you agree? The multiples of 8 are 8, 16, 24, 32, etc. Multiples of 12 are 12, 24. Oh, there it is. Right? How does this 8 become a 12? How does the 8 become a 24? By 1 in the form of 3 over 3. Good. And then how does this 12 become 24? Multiply it by 1 in the form of 2 over 2. Does that make sense?
Yes.
So I did the hard work up front, and now I end up with 21 24ths plus 2, minus 2 24ths ends up being 19 24ths. Same answer. Whether you do the hard work up front or whether you do the hard work at the end, you will end up with the same answer. Does that make sense?
Yes.
So you have options at this point. Most of the time, they're going to tell you that the best way of doing it is to find the least common multiple. True. The other way works too. It really does. That's where good math students, they do whichever one works best for them. If I noticed really quick that the least common multiple was 24, I'd do the least common multiple. If I didn't notice it right away what the least common multiple was, I would do it the first way I showed you. Right? Mm-hmm. It's just how you do it. That's really it. I mean, like I'll give you some of these. Let's do a few practice ones, okay? You guys show me. We'll take a little quiz to see if you guys can handle this. Okay. Number 1, we'll do. Get started. All right, here we go. Let's see how you did. The first one, can I add them the way they sit right now?
No.
Why not? No, they don't have the same denominator. Awesome. What do I do to find a common denominator, Jonathan? Find the least common multiple and make that be the denominator, right? That's one method. What's the other method? Jared,
You can multiply.
multiply by what?
2/5 times 8.
Oh, come on.
1.
1 in the form of, right, multiply one fraction by 1 in the form of this denominator over that denominator, right?
Yes.
And then the other fraction by the other denominator over the other denominator, which is also 1. In this case, it ends up being the same thing. Do you agree? The least common multiple ends up being 40, right? So this is what I would do. I would go times 8 times 8 times 5 times 5. Are you following me? Is that making sense? I had you correct your own so that you could learn from this, and you're looking at what you did compared to what you need to do. 2 times 8 is 16 over 40 plus 15 over 40, right? Can I add them now? Yes. 16 over 40 plus 15 over 40 is 31 over 40. And we're done. Right? Number 2. Can I subtract them the way they sit? No. Slayton, what do I need to do to number 2?
Get the same base.
Not the same base, get the same denominator. Use the right word. Denominator. This is one of those ones that I don't think it matters much which method you do. I recognize really quickly what the least common multiple is. If I didn't, I could do it either way. Honestly, what I generally do right off the bat is I go like this, and I multiply this times 4 times 4 times 10 times 10. That's what I do. It will work 12 40ths minus 10 40ths ends up being 2 40ths. What do I still have left to do, though, by doing that? I have to reduce. Does that make sense? If you recognize that the least common multiple was 20, you go, okay, well then how does the 10 become a 20? Times 2 times 2 times, and how does the 4 become a 20? 5 and 5. It ends up being 6 20ths minus 5 20ths, and the answer ends up being 1 20th. The other way, when we did it before, it was 2 40ths, which you would have to reduce to 1 20th. It's still 1 20th. Make sense? You added them. That's a mistake, right? That's a mistake. How many of you have got both those right so far? Okay. The last one. The last one, some things you can do. Did you realize that in the end, you're going to have to find the least common multiple of all 3? Yes. You realize that, right? You will eventually have to find the least common multiple of all 3 in the end. What is the least common multiple of 5, 2, and 10? 10. Right? So how does this become a 10 then? How does that guy become a 10? Times 2 over 2, right? Times 5 over 5. This is now 4 tenths plus 5 tenths minus 1 tenth, which is 8 tenths. Am I done? No, I have to reduce. What did I just do? 4/5 is the answer. Like I've said, this is stuff that you've been doing for many years now. You should be pretty much a master of this for real. All right. Any other questions about this? Let me give you your homework. No. No.